Hello, and welcome to this Renaissance Synergy training presentation. I'm Warren Miller, one of the Renaissance Synergy support team members. In this short video, I'll describe and demonstrate one of the capabilities of the Synergy platform that dramatically improves the development time of embedded designs: application frameworks. Let's get started. The Renaissance Synergy platform is a breakthrough approach for accelerating your time to market. It provides a unique combination of software, MCUs, tools, kits, and support resources that work together as a complete platform to speed your development cycle. One of the most compelling elements of the platform is the Synergy software package, shown in the diagram on the right. The SSP allows you to design with application frameworks at a high level of abstraction, away from many of the details of hardware implementation. Application frameworks have consistent APIs, making it easy to use them in conjunction with multiple hardware options. The best way to demonstrate this capability is to see how it works using a familiar example. A console interface is probably a familiar example to most of us and is illustrated in the diagram on the right. It provides a simple, text-driven command interface to an embedded system. It typically uses a laptop or PC to communicate with and control the target board. A console interface usually implements a simple menu of commands, often with submenus as well. Common interfaces are UART, USB, or Telnet, using a terminal emulator like Teraterm. Let's look at implementing a console interface within the Synergy software package. One of the application frameworks available within the SSP is a console framework. It has user-configurable menus and provides built-in console functions like a list of commands or a prompt input copy last command. The console framework can use a communications framework to provide input text and output text. Two available communication frameworks within SSP are USB and Ethernet. These communication frameworks provide identical interfaces to the console framework. This means that they can be swapped without writing any code, just by changing the configuration of the modules. The use of common interfaces is done consistently within the Synergy software package, making it possible to focus on development at a higher level of abstraction and with much higher productivity. Here on the right is the complete user code for the console menu with the simple LED toggle command. It uses the console framework to identify the toggle command in the simple one-command menu. More complex menus and commands would simply add to these two structures. A callback is used to execute the toggle command. It just reads the current LED value and then writes the opposite level. The API for the console framework is a single line, shown in the blow-up in the bottom left. The prompt waits for the command and processes it as directed by the previously shown menu and command list. Note that this call is completely independent of a particular hardware implementation. With the interfaces between the console framework and the communications framework identical, it's possible to swap out a USB communications framework for an Ethernet communications framework by just using the SSP configuration window. You can simply remove the modules used for the USB communications framework and replace them with the Ethernet communications framework, as shown in the figure on the right. And you don't need to write any code. Let's take a quick look at the setup and then get into the live demonstration. The target board is a DK-S7G2, and it's communicating initially over USB to my laptop. I'm going to use Teraterm to run the console interface. After I demonstrate the LED toggle command, I'll remove the USB cable and then add an Ethernet cable. I'll replace the USB communications framework with the Ethernet communications framework and build and run the project. I will then reconnect using Teraterm in Telnet mode to show the working console interface. Okay, enough introduction. Let's see the demo. Here's our setup. We have the USB cable connected between the DK-S7G2 and the laptop. Now let's go ahead and run the program. We'll select the console swap, and then we'll run to create a debug output. And once that's completed, we'll be able to run debug. We pick the debug configuration that we want. We'll select it, and then we'll start running the debugger. You hear the audio alert that the connection was good for downloading. And now we'll click run a couple times. And you hear another audio alert that says the USB connection's active. So we can now use TerraTerm over the USB connection. So let's bring up TerraTerm. And we'll make a new connection. We'll select the serial port. And we'll type a question mark to get the list of commands that are available. And you see we have one command available, toggle. So let's type in toggle. Hit return. And if you watch the LED in the bottom middle of the board, you'll see it toggle off and on. Now let's get a close-up so we can see it a little bit better. Toggle on and off from the USB console terminal. So now let's swap that over to Ethernet. We'll stop the debugger. Let's go ahead and swap the cables. We'll take out the USB connection, plug in the Ethernet connection. Now we will go to the Threads tab and select the console thread. This shows the console thread stack with the USB Communications Framework implementation all the way down to the USB port. Let's delete the USB Communications Framework, and we can see the three options available that satisfy the console framework requirements: NetX, USB-X, or UART. We will select NetX, and the required stack is automatically populated for us. Pink blocks are optional components, but blocks with red text require some configuration. By hovering, we can see this block needs an interrupt enabled, which we can do in the Modules Properties tab. We just scroll down to the needed interrupt and select the priority to enable it. Simple. No other configuration settings need to be made, but it is useful to see what some of the key settings are, such as the IP address and mask. We will use the IP address during our Telnet session. Now we can build the project to get ready to run and debug the design. And we didn't need to change any code to switch between a USB console and a Telnet version. We just changed a framework and configured a few settings. After a short time, the project build is complete. We can now start the debug session by selecting the debug configuration to use to launch the session. Once the download is complete and debug is active, we click run a couple of times, and we see from the indicator that the session's running. And we'll see that the Ethernet connection is now active once we started running. So we'll be able to see activity on the port as well as the red LED that says it's active. And now we'll click the Telnet setting for TerraTerm, and we'll make sure we've got the right IP address. And now we'll hit the carriage return and we'll get the prompt again. The question mark shows us the menu. We're going to toggle the LED, same one we toggled before. And typing toggle a couple times, see it toggles. And you'll notice that the TerraTerm window shows that it's using Ethernet, and there's a close-up of the LED from the toggle menu. Toggling via Telnet now over TerraTerm instead of USB. A very simple change, all within the configuration window. This demonstration has illustrated how easy development can be when you can abstract your design away from hardware implementation details. In particular, SSP applications frameworks make it easy to select from hardware options by just using the configuration window. And this is just one of the many productivity-enhancing features found in the Renesas Synergy platform. Visit the Renesas Synergy Gallery at synergygallery.renesas.com to download the Synergy software package today and experience these capabilities firsthand. You'll wish all your designs could have been Synergy designs. Just one more reason to finish that time travel design you're working on.